The next session is on India's sustainable future and implementation challenges and opportunities. So, the last session was fantastic with three very insightful talks. We have seen the supply side, we have seen the demand side, and now listen to some of the implementation challenges and what are the opportunities. So, I would like to invite Dr. Asundi, Executive Director, C-State. Let me introduce him. Dr. Asundi is the Executive Director of Center for Study of Science, Technology and Policy, Bangalore. C-State is a non-profit research organization with a mission to enrich policy making with innovative approaches using science and technology for sustainable, secure and inclusive society. He has been involved in research and development projects in multiple areas, and his current focus is on organizational development. He spearheaded the creation of Center for Air Pollution Studies at C-State and establishment of AI for Social Impact as sector of research. His research interests lie in the areas of information technology for development, and is working on the development of decision support system for a variety of public policy problems. He is a member of IEEE and he holds MS and PhD degrees from Carnegie Mellon University, Pittsburgh, where he is currently adjunct associate professor at the Department of Engineering and Public Policy. Dr. Asundi.
Thank you, Dr. Swarnakar. It's an honor to be here at IIT Kanpur. I could not get into IIT Kanpur, so it's great to be able to speak from the stage here. That said, let me just quickly give you, since we have only 15 minutes, and I want to make sure that you have only one thought in your mind when you leave this hall. Apart from the fact that, I work at C-STEP, we are doing a lot of work in energy, sustainability, climate. I think what I wanted to bring to fore, and especially after the discussions we have had in the morning, I think there is a time now for us to think about a slightly different way about the future for India. And this is essentially the idea that we started with a discussion with Mr. Arun Mehra, who was then member of the Planning Commission. And a significant report came out of the Planning Commission at that time, was where the idea of systems thinking for some of our public policy problems. I think all throughout the day we had somebody telling us about coal, someone telling us about solar, other person telling us about wind and maybe other renewable energy sources. And then of course we also had the demand side perspective. That is, how are people going to consume this energy? After all, energy is not for the sake of energy, it is for some useful and productive use. But at the same time, we also did hear something about water, saying that, look here, there is this problem that if we do this power source, we use renewables, we could end up pumping out a lot more water than we really need. So how do we start thinking about all of these things in a slightly holistic manner? It is, in the end, it's all connected. So this is my motivator and the rationale for why we have to think about it in a particular way. And I'll then put forward a simple model that we have started developing. And all I will say, and I will repeat it at the end. The purpose of my talk here is to get you to get excited about Safari and to be able to use Safari in the things that you are doing today and will want to do tomorrow, as there's a tremendous opportunity to work on something like this going forward, and I feel that is the way to do it. So we are aware of the context, we are committed to climate action, and I think there was a lot of murmuring, a lot of speaking about this idea that human development is a challenge, and especially in India. We have to make sure that we achieve our development goals. I think nobody is going to agree to doing something unless it also means we achieve our development goals. Now, the important thing that we want to state here is that usually we have seen through our experience is that these are being looked at in isolation and the interlinkages are not being explored. And I think this is where we have to think about what the interlinkages are and how do we balance development with climate action in a sustainable manner. So what are the development goals? I think let's be very clear. I mean, it was nice to see SDGs come out, 17 of them. But at the same time, I think we need to identify it for India, because India is unique in some ways. I think Mr. Tiwari talked about UP being a country. I think India is a continent. It's not a country. It is just so much diversity. And in fact, in some of the work that we do in Karnataka, we find that even Karnataka by itself is very different. We have districts that are as developed in some areas as Western Europe, and some that are worse than Sub-Saharan Africa. And you would think that a state that is relatively well developed would not have that discrepancy, but you do have that. So we have a whole series of criteria. So this is, I'll just give you a sense of where we are coming from. We need to think about development goals in terms of housing, healthcare, education, clean cooking, which is really food and nutrition, transport, water, power, and then of course power is a means to achieving this, and then of course food and clean cooking all goes together. So I think these are the aspiration or the goals that we have, and we have set benchmarks based on literature review and expert consultations in the industry, because I think aspiration is at the root of all of the problems. Why are we considering the issue about climate change, or why is the world worried about India quote unquote developing? Because tomorrow if every citizen in India starts thinking about a white picket fence with a 2-acre plot and with 2 SUVs in the garage, then we do not have enough resources to even allow for 30% or less than India's population to deal with that kind of resource consumption. So I think we have to be very clear about what do we aspire for our people or for ourselves. Now, many a rich man will always say that there is no end to it. But at the same time, I think what we have come to realize is that you can create what are called decent quality of life benchmarks. That is, you need to think about it from the perspective of what is a decent quality of life people need to have. Not everybody needs to have that white picket fence with 2 trucks in the garage. I mean, so we have come up with certain benchmarks, and this is again, these reports are available on our website. You can take a look at them. Spent a lot of time engaging with a lot of the policymakers and people on what should be a benchmark for some of these things, and they are obviously not over the top. In housing, we actually came up with the idea that in urban areas, something like 50 square meters for a household is actually a decent quality of life, given the fact that today you have majority of the people sleeping or living in slums that don't even afford that kind of a roof over their head. I think the same goes for healthcare. I mean, the question is how many beds per 1,000 people should we have, and we've come up with certain benchmarks along these criteria. Now, this is where we get into some of the modeling aspects of the work that we are trying to do, is that now that we know what is the driver of our power needs, our material needs, I think the next step for us to think about is, let us not think about it as a problem that we have to solve. I know many of you here have taken JEE or GATE. It's all about solving those problems, and even I went through all of that. But now we are actually in the mode of what we would call a simulation, because this is a dialogue. It's no longer about I have the answer and now all of you have to agree that this is the answer. I think the answer, there are multiple paths to this particular place that we call a decent quality of life, and I think there has to be a discussion around that, and this is why we believe what we need to build is simulations to allow us to examine these issues. While we are doing this, we have to make sure that we also incorporate the interlinkages. That is, what is the implication on land, what is the implication on water, what is the implication on livelihood, things like that need to be looked at simultaneously. And then of course make sure that we achieve those human development goals, which is at the fundament of all this. So at the bottom there is the link to the website. You can go ahead and play around with this tool. As you will see, there are various things. I will get into that. So what is the model structure? What are we really trying to do? What we have here on the left side, if you can read from the back, you have something called socio-economic parameters. We know that over a period of time, the population of the country is going to grow at a particular rate, and it will peak by sometime around 2045. We also know that there is a certain standard of living that we would want to achieve for all people. So those are your socio-economic parameters. And then you have development goals, which also talk about all those DQOL assessments. These are what I would call the drivers for the economy. And then we have modeled four sectors. You have the agriculture, transport, building, and industries, which in turn obviously uses power. So the power sector is modeled outside of this. So it's a fairly big aspect to this. And the idea is that power sector has electricity. You can get electricity demand based on agriculture, based on industry, based on buildings. And similarly, you will also have transport having energy demands. And this all places a burden on what we call our resources, such as water, land, coal, gas, and other entities. On the demand side, and this is where we can get into, we can come up with various ideas on policy ambitions. That is, we will say that housing for all or clean water for all, these are all policy ambitions. We will say, okay, this is what we want. These are also drivers for some of these things. At the same time, we can do what are called technology options, right? So we go from coal to renewables, or we go from going from an individual car to public transport. Those are also technology options. And then, of course, you can also have behavioral shifts where you have people, instead of choosing to ride their motorcycles or their cars or go in a bus, actually walk from place to place. So that's a behavioral shift. Another big behavioral shift can be also in consumption. That is, you choose not to eat certain types of foods because they are actually quite consumptive. So just to quickly run through this model and some simulation results, I just want to show you. The purpose of these results is not to tell you this is the answer. The purpose of the results is to say that you can think about the future in this manner, and you can go in yourself and come up with solutions that you think would be interesting and expand on them. So we always start with what we call as a reference scenario, where we are just filling all the development gaps, but we are not making any consideration for the environment or energy or emissions. We just say that we achieve our development gaps. That's the most important thing. And then we come up with what we call sustainable development scenarios, where we look at different technologies, we look at different behavioral shifts, and so on and so forth. And just for the sake of it, we've also run a simulation in what we call the overconsumption, where let's say you have people come in and say, I do not agree with you, and we aspire for living standards and consumption patterns of the OECD countries, right? So that most of you are aware of. So this is just to give you a sense that, look here, if we don't do this sustainable development scenario, what is it that we will get to? So as you will see, in the reference scenario, the residential electricity demand grows. Today it is at about 1,500. It will grow to about 4,000 kilowatt hours per household per year, which is today's average in Europe. That is the estimate that we will get by 2050. If we continue in the way we say, okay, I want to do development, this is a reference scenario, which is basically development goals without considering anything to do with the environment. The final energy per capita is about 33 gigajoules, which we will just take a look at. And this is consistent with all models today that we see in the Indian ecosystem. We've got our own model called IMRT, which also produces this result. The IESS Niti Aayog also produces this, and so on and so forth. Now, this is where I will show you the first sustainable scenario, and this is where you will see that if we look at sustainability and we look at a number of policy different options, and this is where you will have to get into the details to look at it. The residential electricity demand can remain as low as 980 kilowatt hours per household per year, which is the level we are today, right? Very close to the level we are today. And then the final energy, which was 33 gigajoules, can come down to 25. And here we see key behavioral levers. One is increasing appliance usage, changing appliance usage patterns. I think that's one of the things that there was a little bit of talk about. Alternative construction materials. Again, in agriculture, we see that we will need a dietary shift. And then in transport, of course, more shared, more public mobility, reduced travel. I mean, I think the fact that we are able to do telecommuting, which was a dialogue that has been had since the 90s. And then, of course, the idea of using circular economy, a better way to better way to handle our material usage is one of the ways in which we can do that. And this is the reference scenario in terms of the power supply and coal demand, and we will see that despite what we have, we will still see a 33% in coal with about 50% in renewables, 25, almost 60% in renewables. Fossil fuel free by capacity by 2030 will be 60, by 2050 it goes up to 75%. But if we do the sustainable scenario, we could see the fossil fuel capacity going up to almost 88% by 2050, which is a big jump. And of course, here we will see again different sectors reducing their amount of energy consumption. As you can see, the difference between the two right-hand side graphs on the coal demand actually starts to get plateaued out by 2030. We also see that the annual GHG emissions reduces quite considerably. Of course, I'm only going up to 2050 here. Our work on 2070 net zero is still under review, so I do not want to put it out yet. But once it comes out, I'll definitely circulate that. But you will see that there are a huge amount of savings that can be made. If you see on the right-hand side of the curve, as many of you know, the waterfall diagram, you'll see buildings. And you'll also see there is this idea of there are these better construction materials and improved energy efficiency in industry can actually lead to quite a bit of reduction in cumulative GHG emissions. Yeah, I'm just finishing. So just to give you a sense of the question that I brought up right up front is how do you identify trade-offs? How do we make sure that? So that is some of the things that we have done, and this model is what we call a systems dynamics model. It's a systems dynamics approach model where we look at, so a simple example here is on this idea of building energy demand. You see, if you densify your cities, that is if you make your cities more compact, your transport requirement actually goes down, your urban land requirement goes down. But however, because of the densification, you're going to use concrete and other materials, your GHG emissions actually go up, right? So there is a trade-off there. Unfortunately, your building energy demand also goes up because you need now elevators to take people up and down as opposed to just walking, right? Which is where I think alternative construction materials can play a role in actually reducing your building energy demand while the other aspects go up. Of course, with transport energy demand going down, which is a good thing, but with transport energy demand, it also, if you have more transport, you'll have more local pollutants. And so then you get into the issue of electric mobility, and then this ties into the broader power sector. So just to give you a sense that the model tries to take into account all these interactions, and we need to really understand the scale and size of each of these interactions. It's not just about knowing that those interactions exist, but also the scale and size of it to make an impact on what we are trying to explore. So in our net zero using Safari, just to give you a sense of what are the interventions we have found, in the transport sector, apart from freight, where we'll have to do a modal shift to rail and waterways, and I think there's an opportunity here. We talked about coal going down. Maybe industrial freight can increase in those areas. We are exploring green hydrogen electrification for road freight again. Passenger electrification, passenger modal shift, as you'll see there's a lot of, and then of course biofuels for aviation. These are areas where we can see getting to net zero is a possible interventions. In the power sector, I think the no new coal power plants everyone talks about, no need to talk any more about that. There's increased solar wind capacity and of course energy efficiency. In the industry sector, I think here there are some opportunities. One is on cement, reducing clinker ratio. Steel, I think there's people talking about green hydrogen. In fertilizer, again, replacing hydrogen, replacing natural gas with hydrogen. That is one of the places. And then of course, I think in our models, we have come to realize that we will need some amount of carbon capture and storage. There is no way to get around net zero without that. So with that, I'll just leave with a concluding remark. One is, Safari as a platform is developed for long-term sustainable strategies. It's not to produce answers that we want in the next 3 years or 5 years, but the idea is to actually start thinking about these complex interactions that we will have in our economy when things work out. So that is what we would call our systems thinking framework. It helps us explore the causes, consequences of actions, and aids in the design of, I would think, effective policies. It's a simulator, not a predictor. We are just trying to see what will happen, the what ifs. I think in many of our cases in modeling, we find that we get hung up about the second decimal place of certain numbers. Here, I think we need to just make sure our sign is correct. Are we in the positive or are we in the negative? And finally, I think why I want the students here to take this up, because I think it will help you learn better about the problem that you are exploring. And that is what I really would like. If at least a handful of students here take up saying that, look here, I want to explore Safari, but I want to build a module for this particular sector. We are more than happy to encourage that. So as you know, this lot of contributors to this work. We had a lot of people put in their valuable hours, even telling us what we need to be doing. A lot of the work from the ministries especially. And I think I would leave with the comment of saying, join us on this Safari. Thank you.
Thank you very much, Dr.